Welcome to this final wrap up. Whether you have just completed the course or you are simply curious about what this learning journey is all about, I would like to finish by sharing a few ideas that, in my opinion, capture the real philosophy behind composite engineering. Throughout this course, we have explored composite materials manufacturing processes, tooling design, inspection, testing, and repair philosophy. Although each module focused on a different topic, you have probably noticed that the same engineering principles appear again and again. Rather than thinking of these as isolated subjects, they all form part of a single engineering workflow. Those are the ideas I'd like you to take away from this course and hopefully apply to your own engineering projects in the future. One of the most important lessons is that composites should never be viewed simply as materials. They are complete engineering systems. The final behavior of a composite structure does not depend only on the fibers or only on the resin or only on the manufacturing process. It depends on how all these elements work together: materials, design, manufacturing, tooling, inspection, and quality control. Everything is connected. That is why two parts manufactured using the same materials can perform very differently if the manufacturing process changes. And that is why composite engineering always requires a system level perspective. Another idea that we have repeated throughout the course is that manufacturing matters. In composites, many of the finer properties are not delivered by the material supplier. They are created during manufacturing. Fiber orientation, consolidation quality, curing, laminate architecture, bonded joints, local laminate details, every one of these factors contributes directly to the final performance of the structure. For that reason, a good design on paper doesn't automatically become a good product in reality. Manufacturability is part of engineering design. It isn't something to be considered afterwards. Throughout the manufacturing, inspection, and validation modules, one message has remained constant. Quality is not inspected into a product. Quality is built into the manufacturing process. Inspection is essential. Testing is essential. Process validation is essential. But none of these activities can create quality if it wasn't achieved during manufacturing. Their role is to verify, not to compensate for poor design or poor process control. The best results are always achieved when design, manufacturing, and quality assurance work together from the very beginning. We have also seen that many engineering decisions in composite do not have a single universal answer. There is rarely one solution that is always correct. We saw this when selecting manufacturing processes, when designing molds, when defining support structures, when evaluating defects, and when deciding whether a repair is appropriate. Engineering is about making informed decisions based on technical knowledge, practical constraints, and real world requirements. Two situations may appear very similar while requiring completely different solutions. Developing engineering judgment is therefore just as important as learning technical concepts. If I had to summarize this entire course in one idea, it would be this: composite structures are not designed only to perform. They must also be manufacturable, inspectable, maintainable, and, when necessary, repairable. A design that cannot be manufactured is not a practical design. A structure that cannot be inspected introduces uncertainty, and a product that cannot be maintained will rarely provide reliable long-term performance. The objective of composite engineering is therefore to find the right balance between performance, manufacturability, quality, and reliability. With that, we come to the end of the course. I hope you now have a much broader understanding of how composite structures are designed, manufactured, inspected, and managed throughout their entire life cycle. More importantly, I hope you have developed a way of thinking about composites as engineering systems rather than simply as materials. From this point forward, the best way to continue learning is through practice. Apply these concepts, observe real manufacturing processes, analyze real structures, and continue developing your engineering judgment through experience. Thank you for joining me throughout this course. I hope this is only the beginning of your journey into the world of composite engineering. Good luck, and I hope to see you again in the second Composite Materials Naval Lab course. Remember, In composites, performance is not only designed, it is manufactured.